So last time in chapter number 5, you remember that we have studied a lot of things in chapter number 5, but the last article was about frictional forces. Frictional forces. So in frictional forces, you remember that we defined the frictional forces, which is opposite to the applied force. If this is applied force, then the frictional force will be in this direction. And this is the weight, and this is the normal force. So last time we have seen that F is proportional to the normal force, and F is equal to mu into N. This is the general formula for the frictional force. So in this formula, we can write that mu and N is balanced by mg. So you can write that mg. But this is the case when the body is on an horizontal surface. But if the body is on an inclined plane, then N is not equal to mg. So let's see the other things of this one. So last time we have studied about the static friction, about the kinetic friction. Okay. So experimentally, this is example number your 5.12. So in 5.12 example, it is written that experimental determination of mu s and mu k. So mu s and mu k are what? Mu s and mu k are the coefficient of static friction, and this is the coefficient of kinetic friction. So what he want to explain in this example, he is saying that this is our inclined plane, and this is the body, and its weight is acting vertically downward. You know that if this angle is theta, then this is normal reaction, and this is your uh, components of the weight. And if this is theta, then this is theta, and this will be mg cos theta, and this will be mg sin theta. We know this one. Body wants to move in this way, and this is the frictional force. Okay, so remember, the body try to move in this direction with which component? With this component. Okay, with this component. So the block is placed on an inclined plane, and the inclined angle is increased. If you increase the inclined angle from here to here and then here, until the block starts to move. Surely, if the block is here, it will not move. If the block is here, maybe it will not move. But if the block, if you increase the inclined plane or increase the angle, the block starts to move. So when the block starts to move, the frictional force is opposite to the motion of the block. So we can write the equation. How we can write the equation? The downward motion is mg sin theta minus the upward force is what? Minus F. And this is equal to net force. And net force is MAX because it is along x-axis. So this is one equation. The second equation is vertical. Vertical mean like this one. So in this case, it is N minus mg cos theta is equal to MAY. So here AY is, the body is not moving in vertical direction. It is only moving in the horizontal direction. So AY is equal to 0. So we can write that N is equal to mg cos theta. Now you can see here N is equal to mg cos theta. But if the body is placed on a horizontal surface, then N is equal to mg. So remember this one. Okay. So from here, you can find the value of mg. If you find the value of mg, and this is equal to N over cos of theta, and we put the value in this, the above equation. So if we solve it, I'm not solving this one. I just write the formula. The formula is this one, that tan theta critical. Critical mean where it is going to start, then this is equal to mu s. Okay. So remember this formula. Sometimes in the problems, you have just theta angle and you cannot find the mu s and mu k is not given in the question. So what you will do? So you will apply this formula and find. So similarly, mu k is also equal to tan of theta c dash. I'm writing dash because it is moving and it is not moving. Okay. So in this way, you can find the value of mu k by using this formula. So remember this one. This is very important formula to solve this problem. And similarly, example 5.13, you can solve yourself and it is easy and you can solve it. Try to solve it, okay? So there are some conditions on which the body moves, okay? So it depends on this angle. So here theta is less than theta c, no sliding and the body is at rest. If theta is equal to theta c, then the frictional force is limiting. So remember one thing here, very important formula, and this formula is this one. So if last time we have studied static friction and kinetic friction. So static friction was what? We normally write here S and this is equal to mu S into N, okay? But this static friction is not a constant value. It is a variable value. Variable value in what sense? The sense is this one. If this is a block, last time I have given you example. So its weight is 10 Newton. Suppose you are applying a force here, 5 Newton. It is not moving. You are, because due to this 10 Newton, you are applying 6 Newton, it is not moving. So how much frictional force it will apply? It will apply the 5 Newton. It will apply the 6 Newton. You apply 8 Newton, it will apply 8 Newton. If you apply 10 Newton, then it is balanced. It is not moving. So how much force it will apply? It will apply 10 Newton. So whatever you are applying, it will offers you the resistance of that Newton. It doesn't mean that you are applying here 5 Newton and it will give you 10 Newton. No, if it will give you 10 Newton, then it should move in this direction, but it is not moving. So remember this one, in static friction especially, when you are applying a force of 5 Newton, 6 Newton, 7 Newton, and its maximum capacity is 10 Newton. So it will offer 5 Newton in this way. It will offer 6 Newton in this way. It will offer 7 Newton in this way to balance it. If it will offer 10 Newton, you are applying 5 Newton, it will offer 10 Newton, then it should move in this way, but it is not moving. So this is the point which I want to explain. Okay. After this, kinetic friction. So in kinetic friction, you remember that the body is moving. The body is moving now in this way, and the frictional force is in this way. So this is very simple, that the applied force minus the frictional force is equal to net force. So in this way, you can solve these problems. Okay. So last time, now we want to solve those problems in which the friction is involved. The friction is involved. So when the friction is involved, then the problem becomes a little bit difficult. Difficult in that sense, because you have to apply this formula. F is equal to mu into N. And N is what? N is mg if the body is placed on a horizontal surface. But if the body is placed on an inclined plane, then mu into mg cos theta. Then this formula is this one. If it is horizontal, then formula is this one. So remember this one, please. Okay. So there are some other, in this example number 5.14, you should read this one and solve this one. That a block is placed on a horizontal table, and this is the block, and it is connected by a pulley, and here is a block, and here is the tension T, and this is mass M2. So the weight is acting vertically downward. This is okay, and this is any mass M1. Okay, the tension force direction is this one. The force is applying in this way. If the force is applying in this way, what you will do? You will make the components. One component here and one component here. So remember, you must, when you write the equations of any system, you must write the equations along x-axis. X-axis means this one. This is along x-axis. This is along x-axis. Okay. You must write the equations along y-axis and then solve it. Then solve it. So if there is a friction, you must write that friction. Suppose if this is angle theta and this is F, so this will be F cos theta. Okay. And the frictional force, if the body is moving in this way, the frictional force will be opposite to the motion of the body. So F cos theta minus F, okay, and minus this T, if there is a value, then you can write the net force. So in this way, you can write the equations, okay. And F is equal to what? F is equal to mu into N. Mu, it is moving, so it is K kinetic and into N, and mu K into mg, because it is mg. It is not like this one. So check this example 5.14 and then you will be able to solve this one. Okay. So here you can see that we have discussed some situations in which the block is horizontal or the block is vertical. So I want to discuss with you some other situations. Let's see one situations. In this situation, you can see the block is here, okay, and there is a pulley and block is moving down. So this is the tension and this block is moving down. This block is moving in this way in this acceleration, okay. And this is M1 and this is M2 and this will be M2G and this will be M1G and this is the normal force, okay. So you want to write the equations and the tension is here. Tension is always up away from this pivot point, away from this pivot point, because it is connected with the same string, with the same rope, the tension will be the same. So you want to write the equations. So last time I have written this equation. Again, I'm writing M2G minus T is equal to M2A. M2G downward minus T is equal to net force M2A. In this way, this is balanced by M1G. It is not moving in this way. It is only moving in this way. So the force is what? T minus MA, or T is equal to MA. So T is equal to M1A because this is M1. So these two, from these two equations, you can solve for acceleration M2G over M1 plus M2, and tension you can find M1A. Okay, this is one thing. But if The same thing, the situation is what? The situation is this one. This is the block, and this block is connected by a pulley. Now we have two masses here, two masses. So here the tension is T2, okay? Here the tension is T1. And if I'm saying that this tension is T3, suppose, and this is 2 kg, because this tension and this tension is same. So how you can find the value of this tension? So remember that T1 will be what? So these are the tricks. So here we have 2 kg, suppose. This is also 2 kg. This is also 2 kg. So you want to find the tension of this one. So T1 is equal to 2, this mass, into G minus A. You will apply this formula. Now you want to find T2. This T2. What you will do? You will add the two masses. 2 plus 2 into G minus A. So what will be the T3? So T3 is 2 into A. 2 into A, because there is no G here. This side is no G. G is only this side. Okay. So 2 into A. Now from these equations, you can find the value of the tension. Okay. To find the A value. Yes.
Doctor, isn't there an enforce?
Is there
Enforce.
N force mean? N force. Okay. Yes.
Yeah.
Yes. This is mg and this is N. Yes. This is balanced by this one. N is equal to mg. N
Yeah.
always be when N will be when it is placed on something. Otherwise, no N. Here, no N. In this case, no N. Okay. So if you want to find the acceleration in this direction, what you will do? You will add the two masses, 2 plus 2, and multiply by G divided by the whole masses. Whole masses mean 2 plus 2 plus 2. So this is 6. So if you have acceleration 4 over 6G, you can put the acceleration here, 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 and can solve T1, T2, and T3. So the two blocks are connected. Okay. So remember this one. The second situation, I am discussing the situations. So control the situations and solve the problems yourself. Okay. See, the situation is this one. If this is a block and it is placed horizontal, this is connected with this and other string. And here the force is applying 30 Newton. Suppose this is 2 kg and this is 3 kg. Just taking an example. So here the tension is this way. From this, the tension is this way. The tension will be the same because they are connected with the same string. The string is not changing here. Same string. So what you will do? First, you will find the acceleration of both bodies, because when you apply the force, it doesn't mean that this body will move and this will not move. The both bodies will move. So when both bodies will move, then F net divided by mt. T means total mass. And this is equal to F net is 30 divided by total mass. 3 plus 2 is equal to 5. So 5, 1's the 5, 5, 6 the 30. So 6 meter per second square is the acceleration, and this acceleration is the combined acceleration. Okay. So if you know the acceleration, so what you will do? You can find the individual forces. So you know that the acceleration of this mass is what? 6. The acceleration of this mass is what? 6. So what will be the force on this mass? 12. 6 2 is the 12. F is equal to m. 6 3 is the 18. So the individual force is 12 Newton and 18 Newton. So you want to find the tension. So tension is what? 6 is the acceleration multiplied by the last mass left. Last mass left mean this mass 2, and this is 12 Newton. So you can see it is 12 Newton. Understand? So if you want to find the tension due to this one, it is also 12 Newton. Why? Because this force is 30 minus 18, answer is 12. Because the tension will be the same for the both masses. That's why it is 12 Newton, either for this one or this one. This is the case of two blocks connected with the string. The tension will be the same. But if we have 3 blocks, then what will happen? You are understanding or not? This is a little technical things. Okay. After this situation, the 3 bodies, I am discussing the cases. Okay, this is the horizontal surface, 1 block, 2nd block, and the 3rd block, and this is the F is given 36 Newton, and this is 2 kg, this is 3 kg, and this is 4 kg. This is given. So what you will do? The question is find, suppose if I'm saying this is T2, because these two masses are connected with this string. These two masses are connected with this string. So surely here, if I'm writing the tension T2, here I will write the tension T1. So the tension will be different because they are connected with separate strings. So what you will do? First, you will find the acceleration, and that acceleration is the combined acceleration. So acceleration is equal to what? F net divided by total mass. So 36 divided by total mass is 437 plus 2, 9. And this is 9 ones are 9, 9 fours are 36. So this is your acceleration, combined acceleration. So what will be the individual force? 2 multiplied by 4, 8 Newton. 4 multiplied by 3, 12 Newton. 4 multiplied by 4, 16 Newton. Okay. So what will be the tension of T2? So T2, remember this force, 8 Newton. What will be the T1? Yes, 36 minus 16, and this is equal to 20. So this is the answer. So this is for 3 bodies. Here I discuss with you in the 2 bodies. Here I discuss with you the 3 bodies.
Doctor,
Yes.
here and T1, why
Hmm.
we didn't take 12 Newton?
Why we take 12?
We didn't take 12 Newton. We
No, no.
subtract 36 and 16.
No. Actually, let's see. Here, this is this one and this is this one. Okay. This is this one and this is this one. So between this and this only we will take this T2. Okay. We will take only this T2. Between 3 and 4, we will take T1. So how to find T1? The T1 will be F minus this force, and this force is in this direction. So that's why 36 minus 16, this force. Okay. And
Okay,
this
that
is
means
our answer. Yes.
if you want the last tension, we take the last power.
Yes.
Oh.
Yes, last one. You can solve it yourself, some other problems, and see. Apply this rule and solve it. If you find wrong answer, then ask me. Okay. So after this, now I discuss with you the connected body's motion. The connected bodies motion mean over the pulley and they are connected with the strings. Now see other situations. The other situations are what? If the body is placed horizontal and this is the force and this is the frictional force, okay? And you know that this is mg and this is n. So you can write the equations F minus F is equal to ma if the body is moving in this direction, and n will be mg. This is one situation. In the second situation, if this is a block and this is the force acting with angle some theta, so this is the frictional force and this is the mg, this is mg and this is n. So what you will do, this is F. What you will do, you will make the components, one component here and one component here. This is equal to F cos theta and this is equal to F sin theta. So the horizontal components are what? F cos theta minus. Now we can write the equation F cos theta minus F is equal to net force, and net force is ma. In the vertical direction, upward forces are n plus F sin theta. This one and this one upward is equal to downward mg. So you will write the equation. So in this way you can solve this problem. Understand? Okay. Now see the situation. Third one. The block is horizontal, placed horizontal. The force is acting like this one. This is mg. This is n. Okay. So when you apply the force in this way, it will move in this way. So when it is moving towards right, the frictional force will be this side. So here the angle is theta. What you will do? You will make the components. So this component and this component. Now you want to put the direction, this direction and this direction. Here direction is very important. Now write the equations. X-axis, this is F cos theta and this is F sin theta. So F cos theta in the right direction and left direction is minus F is equal to ma. One equation. The second equation, upward forces is equal to downward forces. So upward force is n. Sorry, n is upward forces. This is downward. This is downward is equal to mg plus F sin theta. So your equation will become these two. Understand?
Doctor,
Yes.
the first equation that F cosine minus F, that F is means friction.
Yes, this F means
Right.
the frictional force. Yes. So this frictional force is mu into N. And this is equal to mu into mg. The total formula will be this one. Yes.
Okay.
Okay. After this, here I have discussed with you all the bodies are placed horizontally. Now we want to discuss if the body is placed on an inclined plane. Let's see this one. So inclined plane is very important. This is the inclined plane making an angle theta. So this is the body, this is the weight, and this is N, and this is the component of mg, and this is the component of mg sin theta. If this is mg, then this is mg sin theta, this is theta, this is mg cosine theta. Okay. If the force is applying upward, the frictional force will be opposite to the applied force. Now all forces are clear. Now we want to write the equation. So one equation will be parallel to the plane. Parallel to plane means like this one. You can understand this is your x-axis. and this is your y-axis. You can understand like this one. So F is upward, F minus down is F, this F minus, this is also downward, minus mg sine theta is equal to net force ma. So F value, again I'm saying that this is equal to, in inclined plane case, F is equal to what? Mu into N. And F is equal to what? Mu into N is what? N is equal to mg cos theta. So here you can see that the vertical components will be what? N is equal to mg cos theta. So here you can write mg cosine theta like this one. So if I want to write this equation complete, then it will be mu mg cos theta minus mg sine theta is equal to m. So this is your complete equation. Okay. After this, another situation, inclined plane. This is inclined plane. This is angle theta. Now the force is acting in this way. This is the direction of the force and making an angle theta. So surely this is the component and this is one component. And this is again mg and this is again mg cos theta. This is remain same. And this is the direction of mg sine theta. Mg sine theta. So this is frictional force because it is moving up. So this is N. This will be F sine theta. This will be F cosine theta. Now all the forces are labeled. Now you want to write the equations. So what will be the equations? Yes, if I want to write the horizontal along the plane equation, then it will be F cos theta minus F, this F, okay, is equal to minus, and this is also in this direction, okay, minus mg sine theta is equal to net force ma. If you want to write in the vertical direction, upward force is this one and this one. So N plus F sine theta is equal to downward force is equal to mg cosine theta. You can write like this. Okay. The last situation which I want to discuss with you. This is the body. This is mg theta. And this is again the components of mg cos theta and mg sine theta. And this is n. Now the force is acting like this one. Now you can see the force is acting like this one and the angle is theta. So what you will do? You will make the components. One component is this side and the other component is this side. Now you can see the situation will be different as we have discussed in the previous. So this will be F sine theta. This will be F cosine theta. Now you can write the equation. If the body is moving up, surely it is moving up, then frictional force will be in this side. So these are the situations which I want to discuss with you, and very important situations. Okay. So you should try to solve the problems of these situations, and then we will see what happens. Okay. After this, so I have discussed with you only the situations of this connected bodies on an inclined plane and on the pulleys. Now you can see one more thing, and some in, and this is blocks. Last time I discussed with you, if one block is here, other block is here, you are applying the force. I discussed with you. So this is the blocks on block. Blocks on block. Blocks on block mean what? This is the horizontal surface. One block is here and the other block is putting here. And you are applying a force F here. This is M1, this is M2. Okay. So see the conditions. The coefficient of friction between the surface and this block is mu1. The coefficient of friction between the both block, this block and this block, is mu2. Okay. So here is the condition. So you just remember this condition. If F is small, if this force is small, then M1 and M2 both move together. Both move together. Due to the frictional force between M1 and M2, they will move together. Okay. This is one condition. The second condition is this one. If F is increased and increased too much, M1 will move forward. I'm writing if F is increased and increased too much, what will happen? M1 will move forward. M1 will move forward and M2 will move backward. Because mu2 is not sufficient. So this mu2 is not sufficient to control it, to hold this mass. So that's why M1 will move in this way and this will move in this way. Understand? So remember this one. This is very important. Okay. After this, now I want to solve some problems of this hanging bodies and see. I solve one problem. The problem is this one. The figure is given. The figure is this one. This is the mass and this is the tension T1. This is the tension T2 and this line and angle is 40 degree. This angle is given. This angle is not given. So the question is, if T1 is equal to 34 Newton and T2 is equal to 24 Newton. Okay. The question is, what is M? What is M? This is the question in this situation. So to find this M, we have to write the equations. How we can write the equations? Okay, see this one. This is this string, this is this string, and you can make and draw the components. So if this is T1, then in front of T1, this angle, in front of this angle, it will be T1 sine of 40. And this line will be what? This line will be like this one. And this line will be T1 cos of 40. If this angle is theta, we don't know this angle. Don't put this one 50 Newton. That 50 plus 40 is 90. No, we don't know. So according to this triangle, this is this component. This will be T2 sine of theta. So this will be T2 cos of theta. Now we have completed all the things. Now we want to write the equations. So in the horizontal way, you can see this is in this direction and it is in this direction, opposite direction. So you can write T1 sine of 40 is equal to T2 sine of theta, because we don't have any other components. So from here, we know the value of T1 and T2. So T1 is 34 into sine of 40 divided by sine of divided by T2 is equal to sine of theta. So from here you can find the value of theta, that sine inverse, and solve this one and put the value here. And when you solve this one, the angle is around 65.5 degree. Okay. So from this equation, you just find the angle theta. If you know this angle theta, now you can solve it very easily. Now apply the components along y-axis. So y-axis is what? This is along x-axis, okay? Y-axis is what? This component is upward. This component is upward. So downward is only mg. So you can write the equation that T1 cos of 40 plus T2 cos of theta is equal to mg. So theta, we know that this is 65.5 here, but this is not a T1. Yes, this is okay. So T2 cos of 65.5. Now from this equation, you can find the value of m. You know the T1 value, you know the cos 40, you know the T2, you know the theta 65.5, you can find the cos of 65.5, and all values you can find from here. And G, you know that it's 9.81. So here write the values and solve it and get the answer m. It is around 3.7 kg. So here in this question, the problem is what? Problem is making the components. If you make the components, then it is easy to solve, otherwise difficult. Yes.
Doctor, why is T1 sine 14 equals to T2 sine theta?
Yes. Why? Because
And then in the bottom we say it's T1 plus T2.
okay, see again. This is actually the situation. In this situation, this is T1 and this is T2. And this line making an angle 40 degree. We don't know this angle. This is, I write theta. So if you want to make the components with this line, this component will be this one and this will be this one from this triangle. Okay. In this triangle, this component will be what? If it is upward, and this will be this one. So I write, this is T1 sine of 40. And then I write T2 cos of 40. This is T2 cos, sorry, not T2 cos of 40. This is T2 sine of 40. Sorry, sine of theta, not 40. Because we are taking this angle theta. So this is in this direction. This is in this direction. They are in opposite direction. So that, and the body is not moving in the along x-axis. Okay. So we can write that T1 sine of 40 minus T2 sine of theta is equal to net force. It is not moving, acceleration is 0, so 0. So that's why I write that sine of 40 is equal to T2 sine of theta. From this equation, I know this value, I know this value, I know this value. I can find the value of theta. This is one answer. Okay, the second question is what?
No, this is my only question. Thank you.
Okay. So similarly, you can solve other problems. Okay, see, I just discussed the diagram. The diagram is this one, that one body is attached here with the string and it is hanging from this side. And the other string is attaching like this one. Okay. So this angle is given 30 degree. And here, this is the horizontal. And this is the mass. Okay. Mass is 2 kg. It is given. Here is tension T1 and here is tension T2. Okay. So the question is find T1. So you want to find this T1. So what you will do? You will make the components of this one. And which tension you will make the component? Only the tension which is like this one, or this one, or this one. This has only one component. This has only one component. So you can make the components like this one. If this is 30, this angle will be what? This angle will be 60 because this is 90. So if this is T2, this I am taking this angle 60, then this will be T2 sine of 60. And this will be what? This will be what? T2 cos of 60. Okay. Now the things are clear. This is T2 cos of 60 upward and downward is what? mg. One thing. The second thing, T1 is in this side and T2 sine theta is in this side. So you can write the equation that T1 is equal to T2 sine of 60. You can write the equation upward is equal to downward. Upward is what? T2 cos of 60. T2 cos of 60 is equal to mg. So from here you can find the value of T2 and put this T2 here and then solve it for T1. This is the problem. I think you understand this one, and I will discuss with you the more situations. Okay. So in the next lecture, we will see more situations. Okay. If you have any other question, you can ask me.
Thank you, Doctor.
Okay. See you in the next lecture, and Assalamu alaikum.